This past May, theCUBE, in collaboration with InfluxData, shared with you the latest innovations in time series databases. We talked at length about why a purpose-built time series database for many use cases was a superior alternative to general purpose databases, trying to do the same thing. Now you may remember that time series data is any data that's stamped in time. And if it's stamped, it can be analyzed historically. And when we introduced the concept to the community, we talked about how in theory those time slices could be taken every hour, every minute, every second, down to the millisecond. And how the world was moving toward real-time or near real-time data analysis to support physical infrastructure like sensors and other devices and IoT equipment. Our time series databases have had to evolve to efficiently support real-time data and emerging use cases in IoT and other use cases. And to do that, new architectural innovations have to be brought to bear. As is often the case, open source software is the linchpin to those innovations. Hello and welcome to evolving InfluxDB into the smart data platform, made possible by InfluxData and produced by theCUBE. My name is Dave Vellante and I'll be your host today. Now in this program, we're going to dig pretty deep into what's happening with time series data generally, and specifically how InfluxDB is evolving to support new workloads and demands in data, and specifically around data analytics use cases in real time. Now first, we're going to hear from Brian Gilmore, who is the Director of IoT and Emerging Technologies at InfluxData, and we're going to talk about the continued evolution of InfluxDB and the new capabilities enabled by open source generally and specific tools. And in this program, you're going to hear a lot about things like Rust implementation of Apache Arrow, the use of Parquet and tooling such as Data Fusion, which are powering a new engine for InfluxDB. Now these innovations, they evolve the idea of time series analysis by dramatically increasing the granularity of time series data by compressing the historical time slices, if you will, from, for example, minutes down to milliseconds, and at the same time, enabling real-time analytics with an architecture that can process data much faster and much more efficiently. Now, after Brian, we're going to hear from Anais Dotis-Georgiou, who is a developer advocate at InfluxData, and we're going to get into the whys of these open source capabilities and how they contribute to the evolution of the InfluxDB platform. And then we're going to close the program with Tim Yoakum. He's the Director of Engineering at InfluxData, and he's going to explain how the InfluxDB community actually evolved the data engine in mid-flight and which decisions went into the innovations that are coming to the market. Thank you for being here. We hope you enjoy the program. Let's get started. Okay, we're kicking things off with Brian Gilmore. He's the Director of IoT and Emerging Technology at InfluxData. Brian, welcome to the program. Thanks for coming on.
Thanks, Dave. Great to be here. Appreciate the time.
Hey, explain why InfluxDB, needs a new engine. Was there something wrong with the current engine? What's going on there?
No, not at all. I mean, I think for us, it's been about staying ahead of the market. I think, if we think about what our customers are coming to us sort of with now, related to the requests like SQL, query support, things like that, we have to figure out a way to execute those for them in a way that will scale long term. And then we want to make sure we're innovating. We're sort of staying ahead of the market as well and sort of anticipating those future needs. This is really a transparent change for our customers. I mean, I think we'll be adding new capabilities over time that sort of leverage this new engine. Initially the customers who are using this are going to see just great improvements in performance, especially those that are working at the top end of the workload scale, with the massive data volumes and things like that.
Yeah, and we're going to get into that today and the architecture and the like, but what was the catalyst for the enhancements? I mean, when and how did this all come about?
Well, I mean, like 3 years ago, we were primarily on premises, right? I mean, I think we had our open source, we had an enterprise product, And sort of shifting that technology, especially the open source code base, to a service basis where we're hosting it through, multiple cloud providers. That was a long journey. I guess, phase one was, we wanted to host enterprise for our customers. So we sort of created a service that we just managed and ran our enterprise product for them. Phase two of this cloud effort was to optimize for like multi-tenant, multi-cloud, be able to host it in a truly like SaaS manner where we could use, some type of customer activity or consumption as the pricing vector. And that was sort of the birth of the real first InfluxDB cloud, which has been really successful. We've seen, I think, like 60,000 people sign up, and we've got tons and tons of both enterprises as well as like new companies, developers, and of course, a lot of home hobbyists and enthusiasts who are using that on a daily basis. And having that sort of big pool of very diverse and varied customers to chat with as they're using the product, as they're giving us feedback, et cetera, has pointed us in a really good direction in terms of making sure we're continuously improving that, and then also making these big leaps as we're doing with this new engine.
Okay, so you've called it a transparent change for customers, so I'm presuming it's non-disruptive, but I really want to understand how much of a pivot this is. What does it take to make that shift from time series specialist to real-time analytics and being able to support both?
Yeah, I mean, it's much more of an evolution, I think, than like a shift or a pivot. Time series data is always going to be fundamental and sort of the basis of the solutions that we offer our customers, and then also the ones that they're building on the sort of raw APIs of our platform themselves. The time series market is one that we've worked diligently to lead. I mean, I think when it comes to like metrics, especially like sensor data and app and infrastructure metrics, if we're being honest, though, I think our user base is well aware that the way we were architected was much more towards those sort of like backwards looking historical type analytics, which are key for troubleshooting and making sure you don't, run into the same problem twice. But, we had to ask ourselves, like, what can we do to like better handle those queries from a performance and a time to response on the queries? And can we get that to the point where the result sets are coming back so quickly from the time of query that we can like limit that window down to minutes and then seconds? And now with this new engine, we're really starting to talk about a query window that could be like returning results in milliseconds of time since it hit the ingest queue. And that's really getting to the point where as your data is available, you can use it and you can query it, you can visualize it, and you can do all those sort of magical things with it. And I think getting all of that to a place where we're saying like yes to the customer on, all of the real-time queries, the multiple language query support. But it was hard, but we're now at a spot where we can start introducing that to, a limited number of customers, strategic customers and strategic availability zones to start, but, everybody over time.
So you're basically going from what happened to, and you can still do that obviously, but to what's happening now in the moment.
Yeah. I mean, if you think about time, it's always sort of past, right? I mean, like in the moment right now, whether you're talking about like a millisecond ago or a minute ago, that's pretty much right now, I think, for most people, especially in these use cases where you have other sort of components of latency induced by the underlying data collection, the architecture, the infrastructure, the devices, and, the sort of highly distributed nature of all of this. So, yeah, I mean, getting a customer or a user to be able to use the data as soon as it is available is what we're after here.
I always thought, I always thought of real time as before you lose the customer, but now in this context, maybe it's before the machine blows up.
Yeah, it is operationally, or operational real time is different. And that's one of the things that really triggered us to know that we were headed in the right direction, is just how many sort of operational customers we have. Everything from like aerospace and defense. We've got companies monitoring satellites. We've got tons of industrial users using us as a process historian on the plant floor. And if we can satisfy their sort of demands for like real-time historical perspective, that's awesome. I think what we're going to do here is we're going to start to like edge into the real real time that they're used to in terms of, the millisecond response times that they expect of their control systems. Certainly not their historians and databases.
Is this available, these innovations, to InfluxDB cloud customers only? Who can access this capability?
Yeah, I mean, commercially and today, yes. I think we want to emphasize that's for now. Our goal is to get our latest and greatest and our best to everybody over time, of course. One of the things we had to do here was we doubled down on sort of our commitment to open source and availability. So anybody today can take a look at the libraries on our GitHub and, can inspect it and even can try to, implement or execute some of it themselves in their own infrastructure. We're committed to bringing our sort of latest and greatest to our cloud customers first for a couple of reasons. Number one, there are big workloads and they have high expectations of us. I think number two, it also gives us the opportunity to monitor a little bit more closely how it's working, how they're using it, how the system itself is performing. And so just, being careful, maybe a little cautious in terms of how big we go with this right away, just sort of both limits, the risk of any issues that can come with new software rollouts. We haven't seen anything so far, but also it does give us the opportunity to have meaningful conversations with a small group of users who are using the products. But once we get through that and they give us 2 thumbs up on it, it'll be open the gates and let everybody in. It's going to be an exciting time for the whole ecosystem.
Yeah, that makes a lot of sense, and you can do some experimentation and using the cloud resources. Let's dig into some of the architectural and technical innovations that are going to help deliver on this vision. What should we know there?
Well, I mean, I think foundationally, we built the new core on Rust. This is a new, very sort of popular systems language. It's extremely efficient, but it's also built for speed and memory safety, which goes back to that us being able to deliver it in a way that is, something we can inspect very closely, but then also rely on the fact that it's going to behave well if it does find error conditions. I mean, we've loved working with Go, and a lot of our libraries will continue to be sort of implemented in Go. But, when it came to this particular new engine, that power, performance, and stability of Rust was critical. On top of that, we've also integrated Apache Arrow and Apache Parquet for persistence. I think for anybody who's really familiar with the nuts and bolts of our backend and our TSI and our time series merge trees, this is a big break from that. Arrow on the sort of in-mem side, and then Parquet in the on-disk side, it allows us to present, a unified set of APIs for those really fast real-time queries that we talked about, as well as for very large, historical sort of bulk data archives in that Parquet format, which is also cool because there's an entire ecosystem sort of popping up around Parquet in terms of the machine learning community. And getting that all to work, we had to glue it together with Arrow Flight. That's sort of what we're using as our RPC component. It handles the orchestration and the transportation of the columnar data. Now we're moving to a true columnar database model for this version of the engine. And it removes a lot of overhead for us in terms of having to manage all that serialization, the deserialization. And, to that again, blurring that line between real-time and historical data, it's highly optimized for both streaming, micro batch, and then batches, but true streaming as well.
Yeah, I mean, it's funny. I mean, you mentioned Rust. It's been around for a long time, but its popularity is really starting to hit that steep part of the S-curve. And we're going to dig into more of that. But is there anything else that we should know about, Brian? Give us the last word.
Well, I mean, I think first I'd like everybody sort of watching just to take a look at what we're offering in terms of early access and beta programs. I mean, if you want to participate or if you want to work sort of in terms of early access with the new engine, please reach out to the team. I'm sure, there's a lot of communications going out and, it'll be highly featured on our website. But reach out to the team. Believe it or not, we have a lot more going on than just the new engine. And so there are also other programs, things we're offering to customers in terms of the user interface, data collection, and things like that. And, if you're a customer of ours and you have a sales team, a commercial team that you work with, you can reach out to them and see what you can get access to, because we can flip a lot of stuff on, especially in cloud through feature flags. But if there's something new that you want to try out, we just love to hear from you. And then, our goal would be that as we give you access to all of these new cool features, that, you would give us continuous feedback on these products and services. Not only like what you need today, but then what you'll need tomorrow to sort of build the next versions of your business. Because, the whole database, the ecosystem, as it expands out into this vertically oriented stack of cloud services and enterprise databases and edge databases, it's going to be what we all make it together, not just, those of us who are employed by InfluxDB. And then finally, I would just say, please, watch Anais and Tim's sessions. These are two of our best and brightest. They're totally brilliant, completely pragmatic. And they are most of all customer obsessed, which is amazing. And there's no better takes, honestly, on the sort of technical details of this than theirs, especially when it comes to the value that these investments will bring to our customers and our communities. So encourage you to pay more attention to them than you did to me, for sure.
Brian Gilmore, great stuff. Really appreciate your time. Thank you.
Yeah, thanks, Dave. It was awesome. Look forward to it.
Yeah, me too. I'm looking forward to see how the community actually applies these new innovations and goes beyond just the historical into the real time. Really hot area. As Brian said, in a moment, I'll be right back with Anais Giorgio to dig into the critical aspects of key open source components of the InfluxDB engine, including Rust, Arrow, Parquet, Data Fusion. Keep it right there. You don't want to miss this.
Time series data is everywhere. The number of sensors, systems, and applications generating time series data increases every day. All these data sources producing so much data can cause analysis paralysis. InfluxDB is an entire platform designed with everything you need to quickly build applications that generate value from time series data. InfluxDB Cloud is a serverless solution, which means you don't need to buy or manage your own servers. There's no need to worry about provisioning because you only pay for what you use. InfluxDB Cloud is fully managed, so you get the newest features and enhancements as they're added to the platform's codebase. It also means you can spend time building solutions and delivering value to your users instead of wasting time and effort managing something else. InfluxDB Cloud offers a range of security features to protect your data. Multiple layers of redundancy ensure you don't lose any data. Access controls ensure that only the people who should see your data can see it. And encryption protects your data at rest and in transit between any of our regions or cloud providers. InfluxDB uses a single API across the entire platform suite, so you can build on open source, deploy to the cloud, and then easily query data in the cloud, at the edge, or on-prem using the same scripts. And InfluxDB is schemaless, automatically adjusting to changes in the shape of your data without requiring changes in your application logic. InfluxDB Cloud is production ready from day one. All it needs is your data and your imagination. Get started today at influxdata.com/cloud.
Okay, we're back. I'm Dave Vellante with theCUBE, and you're watching Evolving InfluxDB into the smart data platform made possible by InfluxData. Anais Giorgio is here. She's a developer advocate for InfluxData, and we're going to dig into the rationale and value contribution behind several open source technologies that InfluxDB is leveraging to increase the granularity of time series analysis and bring the world of data into real-time analytics. Anais, welcome to the program. Thanks for coming on.
Hi, thank you so much. It's a pleasure to be here.
Oh, you're very welcome. Okay, so IOX is being touted as this next-gen open source core for InfluxDB, and my understanding is that it leverages in-memory, of course for speed. It's a columnar store, so it gives you compression efficiency. It's going to give you faster query speeds. You store files in object storage, so you got a very cost-effective approach. Are these the salient points on the platform? I know there are probably dozens of other features, but what are the high-level value points that people should understand?
Sure. That's a great question. So some of the main requirements that IOX is trying to achieve, and some of the most impressive ones to me, the first one is that it aims to have no limits on cardinality and also allow you to write any kind of event data that you want, whether that's a tag or a field. It also wants to deliver the best in-class performance on analytics queries in addition to our already well-served metrics queries. We also want to have operator control over memory usage. So you should be able to define how much memory is used for buffering, caching, and query processing. Some other really important parts is the ability to have bulk data export and import, super useful. Also, broader ecosystem compatibility where possible. We aim to use and embrace emerging standards in the data analytics ecosystem and have compatibility with things like SQL, Python, and maybe even pandas in the future.
Okay, so a lot there. Now we talked to Brian about how you're using Rust, and which is not a new programming language. And of course, we had some drama around Rust during the pandemic with Mozilla layoffs, but the formation of the Rust Foundation really addressed any of those concerns. You got big guns like Amazon and Google and Microsoft throwing their collective weights behind it. It's really, the adoption is really starting to get steep on the S-curve. So lots of platforms, lots of adoption with Rust, but why Rust as an alternative to say C++, for example?
Sure, that's a great question. So Rust was chosen because of his exceptional performance and reliability. So while Rust is syntactically similar to C++ and it has similar performance, it also compiles to a native code like C++. But unlike C++, it also has much better memory safety. So memory safety is protection against bugs or security vulnerabilities that lead to excessive memory usage or memory leaks. And Rust achieves this memory safety due to its innovative type system. Additionally, it doesn't allow for dangling pointers, and dangling pointers are the main classes of errors that lead to exploitable security vulnerabilities in languages like C++. So Rust helps meet that requirement of having no limits on cardinality, for example, because we're also using the Rust implementation of Apache Arrow and this control over memory, and also Rust's packaging system called Crates.io offers everything that you need out of the box to have features like async and await, to fix race conditions, to protect against buffering overflows, and to ensure thread-safe async caching structures as well. So essentially, it's just has all the control, all the fine-grained control you need to take advantage of memory and all your resources as well as possible so that you can handle those really, really high cardinality use cases.
Yeah, and the more I learned about the new engine and the platform, IOX, et cetera, you see things like, the old days, not even today, you do a lot of garbage collection in these systems, and there's an inverse impact relative to performance. So it looks like you really, the community is modernizing the platform. But I want to talk about Apache Arrow for a moment. It's designed to address the constraints that are associated with analyzing large data sets. We know that, but please explain why. What is Arrow and what does it bring to InfluxDB?
Sure, yeah. So Arrow is a framework for defining in-memory columnar data. And so much of the efficiency and performance of IOX comes from taking advantage of columnar data structures. And I will, if you don't mind, take a moment to kind of illustrate why columnar data structures are so valuable. Let's pretend that we are gathering field data about the temperature in our room and also maybe the temperature of our stove. And in our table, we have those two temperature values as well as maybe a measurement value, timestamp value, maybe some other tag values that describe what room and what house, et cetera, we're getting this data from. And so you can picture this table where we have two rows with the two temperature values for both our room and the stove. Well, usually our room temperature is regulated, so those values don't change very often. So when you have column-oriented storage, essentially you take each row, each column, and group it together. And so if that's the case, and you're just taking temperature values from the room, and a lot of those temperature values are the same, then you might be able to imagine how equal values will then neighbor each other. And when they neighbor each other in the storage format, this provides a really perfect opportunity for cheap compression. And then this cheap compression enables high cardinality use cases. It also enables for faster scan rates. So if you wanted to find like the min and max value of the temperature in the room across 1,000 different points, you only have to get those 1,000 different points in order to answer that question, and you have those immediately available to you. But let's contrast this with a row-oriented storage solution instead, so that we can understand better the benefits of columnar-oriented storage. So if you had a row-oriented storage, you'd first have to look at every field, like the temperature in the room and the temperature of the stove. You'd have to go across every tag value that maybe describes where the room is located or what model the stove is, and every timestamp. You then have to pluck out that one temperature value that you want at that one timestamp and do that for every single row. So you're scanning across a ton more data. And that's why row-oriented doesn't provide the same efficiency as columnar. And Apache Arrow is an in-memory columnar columnar data framework. So that's where a lot of the advantages come from.
Okay, so you basically described like a traditional database, a row approach. But I've seen like a lot of traditional databases say, okay, now we can handle columnar format versus what you're talking about is really, kind of native. Is it not as effective? Is the former not as effective because it's largely a bolt-on? Can you like elucidate on that front?
Yeah, it's not as effective because you have more expensive compression and because you can't scan across the values as quickly. And so that's pretty much the main reasons why row-oriented storage isn't as efficient as columnar-oriented storage.
Yeah, got it. So let's talk about Arrow Data Fusion. What is Data Fusion? I know it's written in Rust, but what does it bring to the table here?
Sure. So it's an extensible query execution framework, and it uses Arrow as its in-memory format. So the way that it helps InfluxDB IOX is that, okay, it's great if you can write unlimited amount of cardinality into InfluxDB IOX, but if you don't have a query engine that can successfully query that data, then I don't know how much value it is for you. So Data Fusion helps enable the query process and transformation of that data. It also has a Pandas API so that you could take advantage of Pandas data frames as well and all of the machine learning tools associated with Pandas.
Okay, you're also leveraging Parquet in the platform. Of course, we heard a lot about Parquet in the middle of last decade because it is a storage format to improve on Hadoop column stores. What are you doing with Parquet and why is it important?
Sure. So Parquet is the column-oriented durable file format. So it's important because it'll enable bulk import and bulk export. It has compatibility with Python and Pandas, so it supports a broader ecosystem. Parquet files also take very little disk space, and they're faster to scan because, again, they're column-oriented. In particular, I think Parquet files are like 16 times cheaper than CSV files, just as kind of a point of reference. And so that's essentially a lot of the benefits of Parquet.
Got it. Very popular. So Anais, what exactly is InfluxData focusing on as a committer to these projects? What is your focus? What's the value that you're bringing to the community?
Sure. So InfluxDB first has contributed a lot of different things to the Apache ecosystem. For example, they contribute an implementation of Apache Arrow and Go, and that will support querying with Flux. Also, there has been quite a few contributions to data fusion for things like memory optimization and support of additional SQL features like support for timestamp arithmetic and support for exist clauses and support for memory control. So yeah, Influx has contributed a lot to the Apache ecosystem and continues to do so. And I think kind of the idea here is that if you can improve these upstream projects, and then the long-term strategy here is that the more you contribute and build those up, then the more you will perpetuate that cycle of improvement, and the more we will invest in our own project as well. So it's just that kind of symbiotic relationship and appreciation of the open source community.
Yeah, got it. You got that virtuous cycle going. People call it the flywheel. Give us your last thoughts and kind of summarize, what the big takeaways are from your perspective.
So I think the big takeaway is that InfluxData is doing a lot of really exciting things with InfluxDB IOX. And I really encourage, if you are interested in learning more about the technologies that Influx is leveraging to produce IOX, the challenges associated with it, and all of the hard work questions, and you just want to learn more, then I would encourage you to go to the monthly Tech Talks and community office hours. And they are on every second Wednesday of the month at 8:30 a.m. Pacific time. There's also a community forums and a community Slack channel. Look for the InfluxDB_IOX channel specifically to learn more about how to join those office hours and those monthly tech talks, as well as ask any questions they have about IOX, what to expect, and what you'd like to learn more about. As a developer advocate, I want to answer your questions. So if there's a particular technology or stack that you want to dive deeper into and want more explanation about how InfluxDB leverages it to build IOX, I will be really excited to produce content on that topic for you.
Yeah, that's awesome. You guys have a really rich community. Collaborate with your peers, solve problems, and you guys are super responsive. So really appreciate that. All right, thank you so much, Anais, for explaining all this open source stuff to the audience and why it's important to the future of data.
Thank you. I really appreciate it.
All right, you're very welcome. Okay, stay right there. And in a moment, I'll be back with Tim Yoakum. He's the Director of Engineering for InfluxData. We're going to talk about how you update a SaaS engine while the plane is flying at 30,000 feet. You don't want to miss this.
I'm really glad that we went with InfluxDB Cloud for our hosting because it has saved us a ton of time. It's helped us move faster. It saved us money, and also InfluxDB has good support. My name's Alex Nada. I am CTO at Noble9. Noble9 is a platform to measure and manage service level objectives, which is a great way of measuring the reliability of your systems. You can essentially think of an SLO, the product we're providing to our customers, as a bunch of time series. So we need a way to store that data and the corresponding time series that are related to those. The main reason that we settled on InfluxDB as we were shopping around is that InfluxDB has a very flexible query language, and as a general purpose time series database, it basically had the set of features we were looking for. As our platform has grown, we found InfluxDB Cloud to be a really scalable solution. We can quickly iterate on new features and functionality. Because Influx Cloud is entirely managed, it probably saved us at least a full additional person on our team. We also have the option of running InfluxDB Enterprise, which gives us the ability to even host off the cloud or in a private cloud, if that's preferred by a customer. InfluxData has been really flexible in adapting to the hosting requirements that we have. They listened to the challenges we were facing and they helped us solve it. As we've continued to grow, I'm really happy we have InfluxData by our side.
Okay, we're back with Tim Yoakum, who is the Director of Engineering at InfluxData. Tim, welcome. Good to see you.
Good to see you. Thanks for having me.
You're really welcome. Listen, we've been covering open source software on theCUBE for more than a decade, and we've kind of watched the innovation from the big data ecosystem. The cloud is being built out on open source, mobile, social platforms, key databases, and of course, InfluxDB and InfluxData has been a big consumer and contributor of open source software. So my question to you is, where have you seen the biggest bang for the buck from open source software?
So yeah, Influx really, we thrive at the intersection of commercial services and open source software. So OSS keeps us on the cutting edge. We benefit from OSS in delivering our own service, from our core storage engine technologies to web services, templating engines. Our team stays lean and focused because we build on proven tools. We really build on the shoulders of giants. And like you've mentioned, even better, we contribute a lot back to the projects that we use, as well as our own product, InfluxDB.
But I got to ask you, Tim, because one of the challenges that we've seen, in particular, you saw this in the heyday of Hadoop, the innovations come so fast and furious, and as a software company, you got to place bets, you got to commit people, and sometimes those bets can be risky and not pay off. So how have you managed this challenge?
Oh, it moves fast. Yeah. That's a benefit, though, because the community moves so quickly that today's hot technology can be tomorrow's dinosaur. And what we tend to do is we fail fast and fail often. We try a lot of things. You look at Kubernetes, for example. That ecosystem is driven by thousands of intelligent developers, engineers, builders. They're adding value every day. So we have to really keep up with that. And as the stack changes, we try different technologies, we try different methods. And at the end of the day, we come up with a better platform as a result of just the constant change in the environment. It is a challenge for us, but it's something that we just do every day.
So we have a survey partner down in New York City called Enterprise Technology Research, ETR, and they do these quarterly surveys of about 1,500 CIOs, IT practitioners, and they really have a good pulse on what's happening with spending. And the data shows that containers generally, but specifically Kubernetes, is one of the areas that has kind of been off the charts and seen the most significant adoption and velocity, particularly, along with cloud, but really Kubernetes is just, still up and to the right consistently, even with, the macro headwinds and a lot of the stuff that we're sick of talking about. So what are you doing with Kubernetes in the platform?
Yeah, it's really central to our ability to run the product. When we first started out, we were just on AWS, and the way we were running was a little bit like Containers Junior. Now we're running Kubernetes everywhere, at AWS, Azure, Google Cloud. It allows us to have a consistent experience across 3 different cloud providers, and we can manage that in code. So our developers can focus on delivering services, not trying to learn the intricacies of Amazon, Azure, and Google, and figure out how to deliver services on those 3 clouds with all of their differences.
Just to follow up on that, so I presume it sounds like there's a PaaS layer there to allow you guys to have a consistent experience across clouds and out to the edge, wherever. Is that correct?
Yeah, so we've basically built more or less platform engineering, is the new hot phrase. It's Kubernetes has made a lot of things easy for us because we've built a platform that our developers can lean on, and they only have to learn one way of deploying their application, managing their application, and so that just gets all of the underlying infrastructure out of the way and lets them focus on delivering Influx Cloud.
Yeah, and I know I'm taking a little bit of a tangent, but is that I'll call it a PaaS layer, if I can use that term, are there specific attributes to InfluxDB, or is it kind of just generally off-the-shelf PaaS? Is there any purpose-built capability there that is value add, or is it pretty much generic?
So we really build, we look at things with a build versus buy, through a build versus buy lens. Some things we want to leverage cloud provider services, for instance, Postgres databases for metadata, perhaps. Get that off of our plate, let someone else run that. We're going to deploy a platform that our engineers can deliver on, that has consistency, that is all generated from code that we can, as an SRE group, as an ops team, that we can manage with very few people really, and we can stamp out clusters across multiple regions in no time.
So sometimes you build, sometimes you buy. How do you make those decisions, and what does that mean for the platform and for customers?
Yeah. So what we're doing is it's like everybody else will do. We're looking for trade-offs that make sense. We really want to protect our customers' data, so we look for services that support our own software with the most uptime, reliability, and durability we can get. Some things are just going to be easier to have a cloud provider take care of on our behalf. We make that transparent for our own team, and of course for customers, you don't even see that. But we don't want to try to reinvent the wheel. Like I had mentioned with SQL data stores for metadata, perhaps. Let's build on top of what these three large cloud providers have already perfected. And we can then focus on our platform engineering, and we can have our developers then focus on the InfluxData software, the Influx Cloud software.
So take it to the customer level. What does it mean for them? What's the value that they're going to get out of all these innovations that we've been talking about today, and what can they expect in the future?
So first of all, people who use the OSS product are really going to be at home on our cloud platform. You can run it on your desktop machine on a single server, what have you, but then you want to scale up. We have some 270 terabytes of data across over 4 billion series keys that people have stored. So there's a proven ability to scale. Now, in terms of the open source software and how we've developed the platform, you're getting highly available, high cardinality time series platform. We manage it. And really, as I mentioned earlier, we can keep up with the state of the art. We keep reinventing. We keep deploying things in real time. We deploy to our platform every day, repeatedly, all the time. And it's that continuous deployment that allows us to continue testing things in flight, rolling things out that change, new features, better ways of doing deployments, safer ways of doing deployments. All of that happens behind the scenes, and like we had mentioned earlier, Kubernetes. I mean, that allows us to get that done. We couldn't do it without having that platform as a base layer for us to then put our software on. So we iterate quickly. When you're on the Influx Cloud platform, you really are able to take advantage of new features immediately. We roll things out every day. And as those things go into production, you have the ability to use them. And so in the end, we want you to focus on getting actionable insights from your data instead of running infrastructure. Let us do that for you.
So, and that makes sense. But so are the innovations that we're talking about in the evolution of InfluxDB, do you see that as sort of a natural evolution for existing customers? Is it, I'm sure the answer is both, but is it opening up new territory for customers? Can you add some color to that?
Yeah, it really is. It's a little bit of both. Any engineer will say, well, it depends. So cloud native technologies are really the hot thing. IoT, industrial IoT especially, people want to just shove tons of data out there and be able to do queries immediately, and they don't want to manage infrastructure. What we've started to see are people that use the cloud service as their data store backbone, and then they use edge computing with our OSS product to ingest data from, say, multiple production lines and downsample that data, send the rest of that data off to Influx Cloud where the heavy processing takes place. So really, us being in all of the different clouds and iterating on that and being in all sorts of different regions allows for people to really get out of the business of trying to manage that big data, have us take care of that. And of course, as we change the platform, end users benefit from that immediately.
And so obviously taking away a lot of the heavy lifting for the infrastructure. Would you say the same thing about security, especially as you go out to IoT and the edge? How should we be thinking about the value that you bring from a security perspective?
Yeah, we take security super seriously. It's built into our DNA. We do a lot of work to ensure that our platform is secure, that the data we store is kept private. It's, of course, always a concern. You see in the news all the time, companies being compromised. That's something that you can have an entire team working on, which we do, to make sure that the data that you have, whether it's in transit, whether it's at rest, is always kept secure, is only viewable by you. You look at things like software bill of materials. If you're running this yourself, you have to go vet all sorts of different pieces of software, and we do that. As we use new tools, that's something that's just part of our jobs to make sure that the platform that we're running it has fully vetted software, and with open source especially, that's a lot of work. And so it's definitely new territory. Supply chain attacks are definitely happening at a higher clip than they used to, but that is really just part of a day in the life for folks like us that are building platforms.
And that's key. I mean, especially when you start getting into we talk about IoT and the operations technologies, the engineers running that infrastructure. Historically, as you know, Tim, they would air gap everything. That's how they kept it safe, but that's not feasible anymore. Everything's
can't do that.
Connected now, right? And so you've got to have a partner that is, again, take away that heavy lifting through R&D so you can focus on some of the other activities. All right, give us the last word and the key takeaways from your perspective.
Well, from my perspective, I see it as a two-lane approach with Influx, with any time series data. You've got a lot of stuff that you're going to run on-prem. What you mentioned, air gapping, sure, there's plenty of need for that. But at the end of the day, people that don't want to run big data centers, people that want to entrust their data to a company that's got a full platform set up for them that they can build on, send that data over to the cloud. The cloud is not going away. I think a more hybrid approach is where the future lives, and that's what we're prepared for.
Tim, really appreciate you coming on the program. Great stuff. Good to see you.
Thanks very much. Appreciate it.
Okay, in a moment, I'll be back to wrap up today's session. You're watching theCUBE.
Are you looking for some help getting started with InfluxDB, Telegraph, or Flux?
Check out InfluxDB University,
where you can find our entire catalog of free training that will help you make the most of your time series data.
Get started for free at influxdbu.com.
We'll see you in class.
Okay, so we heard today from 3 experts on time series and data, how the InfluxDB platform is evolving to support new ways of analyzing large data sets very efficiently and effectively in real time. And we learned that key open source components like Apache Arrow and the Rust programming environment, Data Fusion and Parquet, are being leveraged to support real-time data analytics at scale. We also learned about the contributions and importance of open source software and how the InfluxDB community is evolving the platform with minimal disruption to support new workloads, new use cases, and the future of real-time data analytics. Now remember, these sessions, they're all available on demand. You can go to thecube.net to find those. Don't forget to check out SiliconANGLE.com for all the news related to things enterprise and emerging tech. And you should also check out InfluxData.com. There you can learn about the company's products. You'll find developer resources like free courses. You can join the developer community and work with your peers to learn and solve problems. And there are plenty of other resources around use cases and customer stories on the website. This is Dave Vellante. Thank you for watching Evolving InfluxDB into the Smart Data Platform, made possible by InfluxData and brought to you by theCUBE, your leader in enterprise and emerging tech coverage.